We did question, okay? So same paper है 9701 paper 1 2 October November 2018 question number 9 है ये और in this question they are saying that okay, in all pressures are measured in ATM. T2 the partial pressures at equilibrium are shown. They are partial pressures, okay? And which raw is correct? The numerical value of Kp at T2. T2. These are the partial pressures at T2. Okay. So and you can see that. Uh, okay. So first of all, you have to see okay, this reaction is exo or endo. Okay. This reaction is exo or endo. Okay. So remember, this reaction is exo. Why? You can see that the bonds are formed. You can see that the bonds are formed. They are going to react and they are going to form only one product. So means that bonds are going to form. That is only one product is formed. So this is exothermic reaction or addition reaction basically. Okay. And we have to solve it. Like we know that Kp is equal to partial pressure of product, that is Z, divided by the partial pressure of reactant, that is X, and Y power 3 because the coefficient is 3. Okay. Since we know the values, that is 5 chi square, then 2 multiplied by 3 raised to the power 3. If you solve it, so you would be getting 25 divided by 3 3s are 9, 9 3s are 27, 27 times 2 is 54. 25 upon 54. So it should be this and this, okay? Maybe C, maybe D. Since the reaction is exothermic, so that's why the answer is D. Okay, simple. In a chemical system, the particles involved have a large and range of energies. This can be shown on a graph called Boltzmann distribution curve, which statement correctly explains the effect of a catalyst on the particles in a chemical system. So remember, statement 1, a catalyst enables particles with a lower energy. Of course, I told you the definition of catalyst. It was that the catalyst increases the rate of reaction, lowers the activation energy, okay? Without its being used, it provides alternative pathway. So this may be correct. Option B says a catalyst increases the number of, no, it doesn't increase the number of particles. It only lowers the activation energy. Option C says a catalyst increases the number, no. A catalyst increases the value of the most, no. It decreases the activation energy. In option D, they are saying a catalyst increases the value of the most probable energy. No, no, it's not the, it's not a job of a catalyst. Okay. Then question 11 says nitrogen and hydrogen can react together to form ammonia. The formation of ammonia is exothermic. Okay. The formation of ammonia is exothermic. Okay. Then they are saying the formation of ammonia, the rate and yield of reaction can be altered by changing the conditions under which the reaction is carried out, which raw shows the effects of adding iron to the mixture and increasing the temperature. So this was your equation. Basically, this is Haber process in which ammonia is formed. They are saying that reaction is exothermic. Okay. So adding iron. So iron was used as a catalyst. The job of a catalyst has to increase the rate of reaction. It doesn't have any effect on the equilibrium. It's not going to shift the position of equilibrium. Remember. So has no effect on equilibrium yield. It only increases the rate. It doesn't increases the amount of product, first of all. Reduces the equilibrium yield. No, it doesn't have any effect. Now, and they are saying increases the temperature. So since the reaction is exothermic, so according to Le-Chatelier principle, it says that if you are going to increase the temperature of an exothermic system, so the reaction moves backward. When the reaction moves backward, so means that it would decrease the amount of product. So it reduces the equilibrium yield. Yield means amount of product. So option A is correct. Okay. In option B, they are saying increases the equilibrium yield. No, catalyst doesn't increase the amount of product. Increases the no, increases the rate. Yes, it may be correct, but it this is saying has no effect on equilibrium yield, like increasing the temperature. Temperature has effect on equilibrium. So in option D, they are saying temperature has no effect on equilibrium. It's wrong. Question 12 says the melting point of the period three elements, phosphorus to argon, are shown in the table. Okay, okay. Phosphorus exists in the form of P4, okay, and sulfur exists in the form of S8. Chlorine exists in the form of Cl2, and this is argon. This is monoatomic. This is single. Which factor explains the changes in melting points from phosphorus to argon? The changes in electronegativity from no, no melting point only we can relate it with the IMF. We can only relate the melting point with an IMF, intermolecular forces. Option B says uh, the changes in first ionization energy from phosphorus to argon. No, no. The increase in the number of electrons in each atom from phosphorus to argon. Okay, the number of atoms in each molecule. In each atom, it's not an atom, it's a molecule. It's an atom. Of course, option C is incorrect, option D is correct. Option C and D are same, but the only difference is that in option C, they were saying that they are an atom. They're not an atom, they are molecule. So you must know the existence of each molecule. Okay. Because in question, they only say P. So you must know what is P. This is a molecule. It exists in the form of molecule. It's not a single atom. Of course, this is chlorine. They are halogen. And when we were discussing halogens, I told you that they all are diatomic. They exist in the form of two atoms. Question 13 says which observations are made when a sample of silicon chloride is added to a beaker of water. So you know silicon chloride is a covalent compound. So when covalent compound is going to react with water, it reacts with water. It reacts with water. Silicon chloride, when you are going to add in H2O, it's going to form silica and it's going to form HCl. HCl, silica. So they were saying no visible change is observed. No, how is that possible? You can see HCl. Okay. So steamy fumes. Yeah. Steamy fumes means HCl. Steamy fumes. C says the appearance of precipitate is the only observation. No, we can see HCl as well. So why are they saying that the appearance of precipitate is the only observation? No, I know that it's solid, it's a precipitate, but there is another observation, that is this HCl. The appearance of steamy fumes is the only. No, we have two products. One is solid, another one is a gas. So we can see fumes as well. We can see the precipitate as well. I'm going to say this solid as a precipitate. Okay. Question 14 says a 4-gram sample of an anhydrous group 2 metal carbonate, metal nitrate is heated strongly until there is no further change. A solid residue of mass 1.37 gram is formed. Okay, 1.37 gram is formed. So which metal is present? So let's suppose this is nitrate and they are saying it's a group 2 nitrate. When it's going to decompose, it's going to form metal oxide plus nitrogen dioxide plus oxygen gas. Now you have to balance it. I would be writing this. So and then we can say that uh, let's suppose I'm supposing that this is your barium. Okay, so I'm supposing that this is your barium. Um let's suppose this is 4 grams. Okay, they're saying group 2 metal nitrate is heated strongly until there is no further change. A solid residue of mass. Solid residue is this. This is 1.37 grams. This is 4 grams and this is 1.37 grams. Okay. And they are saying which metal is present. They are saying which metal is present. So how can I calculate this? So 4 grams upon upon the molecular mass. I don't know the metal. This is X plus what is the molecular mass of this NO3 twice? What is the molecular mass of this NO3 twice? So it would be 14 into 2 plus oxygen is 16 into 6. Can you tell me the answer? Yes, I think so. 324, I remember. I think. What's the answer? Yes. Hmm?
Yes, sir, it's 124.
124
Yes.
is equal to mass over metal. X plus oxygen is 16. So we have to find out X. We have to find out X. 4x plus 16 times 4 is equal to 1.37 times x plus 124 times 1.37. So you have to find out the value of x. X would be the MR of that metal. So we can find out from the periodic table by matching the MR with the particular element. Then you would know the what the element is. Okay. So what's the answer? It's 40. Of course, calcium is 40. Okay. Simple. Question number 15 says in which row are all elements statements comparing magnesium and barium correct? Magnesium and barium is correct. Okay. So we can say that. So we can say that um, fourth ionization energy. Fourth ionization energy. Uh, Magnesium and barium na down the group ionization energy decreases. This is understood. This is understood that down the group ionization energy decreases. So of course the ionization energy of magnesium would be higher and the ionization energy for the barium would be lower. Okay. So magnesium is higher and higher. A or B may be correct, of course. A or B may be correct. Okay. So then we have to see reaction with water. Magnesium is more reactive than, sorry, barium is more reactive than magnesium because as we go down the group, the reactivity increases. So barium would give you the faster reaction. Of course, option B is correct. It's very easy question. Question 16. Can you try this question? Can you try this question? Which statement about the halogens is correct? Okay. So iodine cannot behave as an oxidizing agent. You know, oxidizing agent is the one which reduces itself, which reduces itself. So, so iodine is a non-metal. It generally loses electron. So when something loses electron, when something loses electron, you know what does it mean? When it would lose electron, it would be oxidized. It's a reducing agent. It's not an oxidizing agent. So this is incorrect. The volatility of the elements increases from chlorine to no, it decreases. IMF increases down the group. That's why When an equimolar mixture of chlorine and hydrogen is exploded, like I mean to say H2 plus Cl2, only one product, of course, only one product is formed. That is this. C is correct. Okay. Question 17 says chlorine reacts with both hot and cold hydroxide to form products containing chlorine. Cold sodium hydroxide forms sodium chlorate X and hot sodium hydroxide forms sodium chlorate X, Y. X and Y are oxidation numbers. X and Y are oxidation numbers. So how can you identify this? You must know the equations, you must know your equation. I'm telling you, when the chlorine is going to react with cold sodium hydroxide, it was producing, if you remember, NaCl plus NaClO plus H2O. Okay, this is for cold and this is for hot. When chlorine was reacting with sodium hydroxide, it was producing sodium chloride, it was producing sodium chlorate, that is NaClO3 plus water. If you can see this, the oxidation number in this is -2 plus 1. So it should be plus 1. -6 and plus 1. It should be plus 5. Okay. It should be plus 5. It should be plus 5. So which equation is correct? Which equation is correct? So, so X is the oxidation number for the cold. For the cold. So this is X. In this, X is equal to 1 and Y is equal to plus 5. Okay. So if you're going to put these values in this equation, so Y is plus 5, X is 1, minus 6. So minus 5 is equal to plus 5. No, this equation is wrong. Mathematically, this is wrong. It should be equal on both sides. You can try option B. Plus 5 is equal to plus 1 minus 4. It would be minus 3 is equal to plus 5. No. Let me try C. Plus 5 is equal to plus 1 plus 4. Of course, 5 is equal to 5. Yes, option C is correct. Okay, it's easy. Question number 18 says the product of the contact process is Z. Of course, this is H2SO4. Of course, the product of contact process is H2SO4. Which reaction or process leads to the formation of a gas that can neutralize an aqueous solution of zero acid? So when something is going to neutralize Z, so means that it should be basic. It's an acidic. It's an acidic. So something which is going to neutralize that acid should be basic. Atmospheric lightning. Atmospheric lightning means that NO is produced from atmospheric lightning. It's an acidic product. It's a non-metal oxide. How can it neutralize that acid? Okay, this is wrong. Combustion of fuel in an internal, of course, it's going to produce carbon dioxide, which is also an acidic gas. Okay, we need basic thing. The Haber process, which is going to produce ammonia. Ammonia is basic. Ammonia, option C is correct. Okay. Group 2 nitrate, it's going to produce NO2 gas. NO2 is also an acidic gas. It's a non-metal oxide. Okay. Question number 19 says if ammonium cyanate is heated in the absence of air, the only product of the reaction is urea. No other products are formed in the reaction. What is the formula of the cyanate ion present in ammonium cyanate? Of course, the formula of the ammonium cyanate is the formula for the ammonium cyanate is ammonium is NH4 plus. Ammonium means NH4 plus. Okay, means NH4 plus. Okay, so they are saying that urea, that is CONH2, CONH2. Okay, ammonium cyanate is heated in the absence of air. The only product of the reaction is urea. That is this. No other products are formed in the reaction. Okay, so ammonium cyanate is this, ammonium cyanate. This is your product. Okay, and this is your reactant and this is your product. Okay, and ammonium is plus 1, by the way. So how many elements we have? C, O, N, or H? Of course, it would be having NH and it would be having CO as well. Of course. Okay. So CONH2 means that CONH2 means that uh, you can say one nitrogen and four hydrogen. So means that one nitrogen means one nitrogen is -3 and +4. So overall charge is +1. I'm talking about this ammonium. Okay. And if you can consider carbon monoxide, its carbon is 1. Okay. Carbon is 1. And then we have one oxygen as well. Then we have two nitrogen atoms. We have two nitrogen atoms. So two nitrogen means that -6. Each nitrogen is going to have -3, and we have four hydrogen atoms. So +4. We have +4. So it would be -2. It would be -2, and then we have CO as well. Then we have CO as well. So if you can consider this CO and 2, CO and 2, so you can see this is 2. You can see this is 2. So C is +4, oxygen is -2, and nitrogen is -3 is equal to -1. Okay, is equal to -1. Can you tell me the overall charge on this? We have multiple ways to do this question. Okay, you're supposed to think by yourself that what should be the method to do this question, because we have multiple methods to do this. You can relate it with the oxidation number. Okay, so you can solve it by the by like you can say by doing with a simultaneous equation. Okay, because you have two compounds, so you can relate them. You can relate them. You have to think by yourself. Then I'm solving this. It's a common question related to simple charge. Simple charge. And this is very important statement. No other products are formed in this reaction. Means that you have only this and this. In the whole equation, you have only this. Let me clean this. Yes. Mhm. Done? Okay, okay. I'm doing this. So I'm going to match all the answers. Okay. Let's suppose the reactant was ammonium cyanate. Ammonium, and I'm considering this is your cyanate ion, COCON2, CON2, and this is minus, and this is your product, that is urea, CONH2 twice. Okay, CONH2 twice, right? Then is the charge balanced? Is the charge balanced? Okay, first of all, you have to find out this, right? First of all, you have to find out this, is the charge is balanced? You know, ammonium is plus 1, okay? So CON2 is equal to minus 1. You can find out the value for N. 2N 2N is equal to minus 1. Okay. What is the charge on this CO? What is the charge on this CO? You know, C is plus 4, oxygen is minus 2. C is plus 4 and oxygen is minus 2. Okay, so the overall answer is plus 2. So 2N plus 2 is equal to minus 1. I have to find out the value for N. So 2N would be equal to minus 1 and minus 2. That is equal to minus 3. Then N is equal to minus 3 by 2. You can save this. Then you are supposed to solve option B. Then you are supposed to solve option C. Then you are supposed to solve option D. And then you are supposed to solve it, the oxidation number of this nitrogen. The option which is going to match, like if let's suppose this is plus 1, so it should be plus 1. Okay, so you have to do a lot of working in this. But I'm telling you this, in this question, like in this option, ammonium NH4 CNO is equal to CONH2 twice. Okay, they are going to match. If you are going to solve it by doing, when we were discussing how to balance redox equation, if you remember how to balance redox equation, so in that topic I told you how to balance a redox equation. So first of all, we have to balance the metals, then we have to balance the non-metals, then we have to balance electron by, we have to balance the charge by adding electron. So you can solve it by that method. The charge should be balanced. So when you are going to opt this option, so when you are tweaking this, so now the charge is balanced. In other options, this is minus 2, this is minus 2, this is minus 1, but we have two nitrogen atoms. We have two nitrogen atoms. So when you would be balancing equations with option A, B, and D, so then you would see that the equation wouldn't be balanced. But when you are going to take this, the equation would be balanced. You are supposed to do working, and if you are failed to do working, then do let me know. Okay. Question 20. It's related to organic chemistry. There are three structural isomers with the formula C5H12. Like this is pentane. Which formulae correctly represent these three structural isomers? A, B, C, and D. Structural isomer means that the molecular formula should be the same and the structural formula would be the different. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And you can see this is just like that. CH3, 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 CH3. Okay. In this structure, you can see that 1, 2, 3, 4, 5. Yep. This is just like that. Okay. And option A means that it's a straight chain structure. It's a straight chain structure. So what is the definition of a structural isomer? The molecular formula is the same and the structural formula would be the different. Of course, option A is correct because in this option, formula is same. C5H12, C5H12, C5H12. But the structure is different. Of course, option A is correct. But what about option B? What about option B? Option B means that 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. But the thing is that this and this, they are the same. They are the same. You know why? Let me tell you this. What is the name of this? What is the name of this compound? You will say it's 2-methyl butane. And what is the name of this compound? What is the name of this compound? 2-methyl butane. They are the same thing. Option B is incorrect. What about C? What about C? Of course, this and this, they are the same. It's 2-methyl butane. It's 2-methyl butane. The same thing. Okay. 2-methyl butane. 2-methyl butane. That's the reason option A is correct. Question number 21. The diagram shows a molecule that has a sigma bond and a pi bond. How many sigma bonds are present in this molecule? Sigma bond means this sigma bond is a single bond, single covalent bond. Whether the bond is between carbon-carbon, whether the bond is between carbon and hydrogen. Okay. So 2, then 3, then 4, then 5, then 6, 7, then 8, then 9, 10, 11, 12, 13, 14, 15, 16, 17, or 18. C answer is correct. You are supposed to draw the displayed formula, then you would be able to know. The double bond is a pi bond. This is the pi bond, this is the pi bond, and this is the pi bond. Okay. Question number Question number 22. Polyethylene is made by the polymerization of ketene. Which statement is correct? The monomer is and the polymer have different empirical formulae. The monomer and the polymer have the different empirical formulae. No, they are the same. You know how? Let's suppose this was the monomer. Let's suppose this was the monomer and this same. So why they are saying they have different empirical formulae? Option A is incorrect. Option B, the monomer can be oxidized without heat, whereas the polymer cannot. Oh, without heat. Okay. If you remember, we have oxidized. We did oxidation of alkene by hot cheminophore and by cold cheminophore. So in cold cheminophore, we were not providing any type of heat. It may be correct, but we have to check option C and D as well. The monomer can be used as a fuel, whereas the polymer cannot. No. Okay, it's incorrect. The monomer has greater van der Waals forces than the no. Polymer has a greater van der Waals force. So option B is correct. Okay. Option B is correct. Right. Question number 23. Compound P reacts separately with KOH and HBr. What are the mechanisms of these two reactions? Compound P is this, and they are being with KOH and HBr. So KOH. With the KOH, it would be giving you CH2. Uh, Let me draw the structure. This is C, then C, then C, then C. This we have two hydrogen atoms. It has a double bond. And then this is CH2, CH2, then CH2, then CH2. It has a Cl. Then it has a Cl. Okay. Let's suppose it's going to react with HCl, like KOH. It's going to react with KOH first. So KOH like means that OH minus. It has a lone pair of electron. It's a nucleophile. Be substituting this chlorine, of course. It's a nucleation reaction. If this is partial negative, this carbon would be partial positive. So this OH minus is going to attack on this carbon and it would be replacing this. It should be a nucleophilic substitution. Option C and option D may be correct. Now we have to see HBr. Now we have to see HBr. HBr can do addition reaction. You know, it's partial positive and partial negative. So the double bond would be attacking on this and the bromine would be attaching on another carbon atom. So it would be electrophilic addition reaction. It's not a free radical because they have not mentioned that we are going to provide sunlight. We are not going to provide, like you can say, UV light. Okay. 24. Which statement about compound Q is correct? It would be polymerized to give a polymer with the repeat unit this. Like I always say that whenever you're going to do polymerization, so you are supposed to make it in a proper manner like this. This is PH3. This is CO2CH3. This is CH and this is CH2CH3. Is this matching with this? H and CO2. No, 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 no. With CO2, CH3, there would be no. Option A is incorrect. C option B. CO2, CH3 and CH3. CO2, CH3 and CO2, CH3. Oh, okay, okay, okay. About Q compound Q is then they are saying it reacts with chlorine. It reacts with chlorine by a free radical mechanism to give. By a free radical mechanism. So in a free radical reaction, the double bond wouldn't break down. Okay, so in option B, they have broken down the double bond, double covalent bond. And this is incorrect. Okay. C says it reacts with cold, dilute, acidified manganate to give this. In a cold KMNO4, I told you that the diol would be formed. The diol would be formed. So yes, option C is correct because in this option, the diol is formed. Like here, OH and then OH. That's it. 25 says a halogenoalkane has the molecular formula C5H11Br. The halogenoalkane does not form an alkene when treated with ethanolic sodium hydroxide. Okay. What could be the halogenoalkane? Okay. What could be the halogenoalkane? So let's try option A. It's butane, 1, 2, 3, 4, and 1 bromo, and then 2 methyl. 1 bromo, and then 2 methyl. So when you would be reacting this with the uh, ethanolic sodium hydroxide, so sodium hydroxide can remove HBr and the double bond would be formed. So the alkene can be formed by this. Option A is incorrect because in this question they are saying the halogenoalkane does not form an alkene, but option A is going to form alkene. This is incorrect. Option B says 2 bromo 2 methyl butane means that this is bromine, this is methyl, this is H. It can form alkene by removing this HBr. It's also incorrect. 3 bromo pentane. Pentane is this. Pentane 1, 2, 3, 4, 5, and this is 3 bromo. Of course, it can form alkene because this and this may be removed by NaOH. Let's try option D. Dimethyl propane means that this is dimethyl propane, and let's suppose this is bromine. Of course, if you are going to remove Br, so on the adjacent carbon atom, there should be H directly attached so that I can remove HBr. But but in this structure, there is no H present on adjacent carbon atom. That's why it cannot form alkene. So this option is correct.
Sir, can you
Question
explain
20.
the question again?
Okay. Okay. Basically, in this question, elimination reaction is going to take place. Of course, sodium hydroxide is a base. It can remove an acid. In your structure, this is HBr. Na would be taking this Br and it would be forming NaBr, and OH would be taking its H and would be forming water. So the double bond would be formed. So means that alkene is produced. So this option is incorrect because according to the question, alkene shouldn't be produced by this molecule. If you're going to see option B, this is 2 bromo 2 methyl butane. So Na would be reacting with this Br and OH would be reacting with this H. It would be forming water and sodium bromide, and you would see that the alkene would be produced. You would see the double bond over there. It is also forming alkene. If you can check option C, 3-bromopentane. HBr can be removed. It can form alkene as well. But in option D, HBr cannot be removed. I have Br, but where is H? There is no H on adjacent carbon atom. So HBr cannot be removed. So I can say alkene cannot be formed. That's why option D is correct. Okay, simple. 26 says the reaction of four organic compounds are given in the table. Which compound could be propane to all? Which compound could be propane to all? So in the first column, they are saying that when oxidized with dichromate gives an organic product with a boiling point greater than the original compound. Okay, propane to all is alcohol. So, okay, when oxidized with Cr2O72 minus H plus gives an organic compound with a boiling point greater than the original product. Uh, so propane to all would be giving you a ketone. है ना? Propane to all after oxidation it would give you ketone. And ketone has a lower boiling point than that of alcohol because alcohols are going to have hydrogen bonding in it. When there is hydrogen bonding, so the boiling point would be higher. So this is no. Option A is incorrect. And when added to ethanoic acid and a few drops of H2S gives a sweet smelling compound. So ethanoic acid is going to react with this propane to all. It would be giving you an ester, but they're saying no. Why they're saying no? Yes, should be yes, because it would give you an ester because we have an observation that is sweet smelling product. Let's try B. B says it should be no, of course. Okay. And yes. Okay. B is correct. Why not C and D? Because in option C and D, they are saying yes, yes. Means that ketone is going to have a higher boiling point than alcohol. How is that possible? How is that possible? Okay. Compound X has the empirical formula C2H3O. Compound X reacts with 2,4-DNPH. That is the test to check the presence of carbonyl, to check the presence of this C double bond O. To give an orange precipitate and also decolorizes warmed acidified potassium manganate solution, KMNO4 solution. What could be the identity of X? So it can give you 2,4-DNPH because this is an aldehyde. This is a ketone, ketone, yes, yes, yes. This is a carboxylic acid, no. This is carboxylic acid, no. This is your aldehyde, yes. So then compound X reacts with 2,4 to give an orange and also decolorizes warmed acidified potassium manganate. So, potassium manganate can oxidize only aldehyde. It cannot oxidize ketone. Remember, it cannot oxidize ketone. Remember. Okay. So, this is carboxylic acid. It cannot be oxidized further. This is carboxylic acid. Okay. It cannot be oxidized further. And you can say that option A should be correct. Option A should be correct. But you would say that, sir, why not option D? Why not option D? Because in D we have aldehyde, it can be oxidized to carboxylic acid. Of course, option B is incorrect. This is a ketone, it cannot be oxidized. It has a carboxylic acid, it cannot be oxidized. But why not option D? They have given you the empirical formula. You are supposed to match with this empirical formula. So you can see that it has C4H1, 2, 3, 4, 5, 6 and O2. So the empirical formula would be C2H3O because I'm going to divide it by the smallest number, that is 2. If you're going to check this, it has 1, 2, 3, 4, 5, 6 carbon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens and we have 1, 2, 3 oxygens. What's the empirical formula if you're going to divide it by 3? You wouldn't be getting this. Of course, option A is correct. That's why. Okay, it's easy. Compound Y gives methanol and sodium ethanoate on treatment with aqueous sodium hydroxide. What is the structure of Y? Give methanol and sodium ethanoate. Of course, it should be an ester. It should be an ester. So methanol means one carbon alcohol and sodium ethanoate means it's ethanoic acid. So you are supposed to solve all the esters. The option in which you would be getting this product would be correct. Let's suppose this is the ester. This is O and this is CH3. Okay. If you're going to break it down, so you would be getting this and CH3, C double bond O and Na. So this is methanol and this is sodium ethanoate. Option A is correct. Okay. If you are going to try option B, so you would see that in this option you would be getting propanoic acid, not ethanoic acid. So option A is correct. Okay. Which compound can be used to make propanoic acid by treatment with a single reagent? Propanoic acid. Propanoic acid. Okay. So what's the option? Which can only give you propanoic acid, like 3 carbon atoms. Of course, option A is correct. You know why? When you're going to break down this double bond, so propanoic acid would be formed because it's a 3 carbon atom. And for this, CO2 would be produced. If you remember when we were discussing oxidation of alkene by hot KMNO4. If you're okay, it cannot be oxidized. It can be oxidized, but it would be giving you ketone because this would be a secondary alcohol. And also it would be giving you a ketone. They're talking about propanoic acid, means they are talking about uh, carboxylic acid. Okay, they are talking about carboxylic acid. What could be the structure of L? What could be the structure of L? Yes, you are supposed to match this with your table that would be provided you in that paper. Okay, I can see the peak. I can see the peak. This would be the peak of OH. I remember the shape. I told you you have to memorize the shapes. The range of this peak is 3200 to 600, 6000. Sorry. Okay, of course, this should be an alcohol. And you cannot see the peak at 1600, like 1600. That would be the peak of C double bond O. So there is no C double bond O in this. Of course, option A is incorrect because this is a CO peak. I don't have any CO in this spectrum. Okay, I don't have any CO in this spectrum. Okay, this is aldehyde. Of course, in this aldehyde, you would be having CO. No, there is no CO peak. It should be correct because OH, OH, and OH. Yes, it's an alcohol. Of course, it's a carboxylic acid. No, this is not a peak of carboxylic acid. So this is very easy question. You can solve it in a within a minute. Within a minute. Within a minute. Okay.